Okay, now we're going to take a look at example 3, but I'm not going to go through example 3 because it's terribly written. I'm going to do a different example that I've totally stolen from one of the resources that I listed in the resource page, so you can see them explain it probably better than me if you'd like. But, you know, I'll pretend I have a job and do that. So let's start with a statement. And this statement is going to be, if it's my birthday, then I get cake. So this has the traditional if-then format. Our P statement is, it's my birthday. And that implies our Q, which is, I get cake. Hooray! Now let's take a look at the converse statement, which is, if I get cake, then it's my B-day, which is Q implies P. Now, important thing about the converse. The converse is not necessarily true because the statement is true. This is just if I ask you, given a statement, what is the converse, you're basically flipping the direction. Instead of P implies Q, Q implies P. Now, it's possible that this is true, but not necessarily true. That's an important distinction. So we have the statement, we have the converse. Now let's take a look at the inverse. Our inverse statement is, if it is not my birthday, then I do not get cake. Now, the key things I want you to notice here are the nots, right? Those are negations. So what is this really saying? This is saying not P, right? P is my birthday. Not P implies not Q. And finally, we want to look at the contrapositive statement. The contrapositive statement is, if I do not get cake, then it is not my birthday. Think about that. This not only flips the order, but it also flips the, let's call them the signs, right? So this is not Q implies not P. Okay, key things I want to point out here. The statement and the contrapositive, what do you notice about them? They have a flipped direction and sign. Well, guess what? When you flip the direction and the sign, you don't change the meaning. So the statement and the contrapositive have the same meaning. If it is my birthday, then I get cake. If I do not get cake, then it is not my birthday. That has the same logical meaning. You should also have noticed by now that the converse and the inverse also flip the sign and direction for each of them. So the converse and the inverse have the same meaning. You could say the inverse is the contrapositive of the converse, but that's getting a little crazy, right? So the statement and the contrapositive have the same meaning. The converse does not have the same meaning, and the inverse, because it means the same as the converse, also does not have the same meaning. They could be true, but they're not necessarily true. But the contrapositive, if the statement is true, the contrapositive is true. That's an important key thing, which means anytime you see a P implies Q statement, you can replace it with the contrapositive. Okay, let me move this kind of off to the side, and then let's draw a truth table to go over this in a little bit more detail. Okay, so P implies Q. Remember, if P is 0, it says nothing about the implication, so we assume that to be true. If P is 1 and Q is 0, well, that proves our implication false, so that's false. If P is 1 and Q is 1, that proves our implication true. Or in that instance, our implication is true, so we label that one as true. So not Q implies not P, right? Think about this. Q is 0, not Q would be 1. That implies not P. P is 0, knotted, that becomes 1, so there, that is true. Not Q, well, Q is a 1 here, so it doesn't matter what P is, because when we not Q, that means that this side is 0, so we always assume that to be true. And we can actually go down here and say that that's true for the same reasons. Now on this line, or on the third line down, not Q becomes 1, and that implies not P. Well, P is 1, so if we negate that, we get 0. Well, that means that the implication is false, so that's 0. And like we said, that's the contrapositive. It is the same as the original statement. Okay, Q implies P, which is not the same as our original statement, but that is the converse, right? Well, Q is 0 here. Remember, everywhere Q is 0, we assume it to be true, right? When Q is 1, but P is 0, well, that means our implication is false. When Q is 1, but P is 1, that means our implication is true. So we see that Q implies P is not the same as P implies Q logically, right? Whereas the contrapositive is logically the same, so they're just two different forms. The converse is different. It has a different truth table. Then we have not P implies not Q, which is our inverse. And for this one, everywhere P is 1, we can just assume it to be true. When P is 0, not P becomes 1, and Q is 0, not Q becomes 1, so that means our implication is true there. For the second line, not P, not 0 is 1, implies, and then we have not Q. Well, when you negate 1 over here, that becomes 0, so that's false. And look, it is exactly the same as our converse, which is what we said before, that the inverse and the converse are the same thing. So I hope you're starting to see this. When we change the signs and flip directions, it is the same statement. Good. I don't know why I said good. You didn't answer me, but you might have answered me. Hopefully you answered me and said, yes, this makes sense. You're awesome. Finally, I'd like to take a look at the double implication. P implies Q and Q implies P. Well, in this case, P is 0. So it doesn't matter with the P implies Q part, doesn't matter what's on Q. Q is 0, so it doesn't matter what P is, so that's true, right? If we come down here, P is 1, and it implies Q is 1, which it is. Q is 1, which implies P is 1, which it is. In each of these other cases, P is 1, which means it implies Q, but Q is 0, so that's false. In this case, Q is 1, which implies P, but P is 0. So that's false. And what do you notice? Well, P and Q double implication is exactly the same as P equals Q, right? And that's what we said at the very beginning of this chapter, that double implication equals and the word equals are all the same. Okay? Okay. That's all I'm going to go over from example 3, but make sure you read it in detail. And in particular, I did not draw the last truth table. Take a good look at that last truth table and make sure you understand it. The last truth table has some other ways, based upon what we learned here, of interpreting the implication. And you can use that during your homework exercises in order to break down some of these propositions. All right? If you have any questions, ask them in the forum below.